Hi guys, hello. Hi everyone. I'm back, guys. How are you all? So sorry for the delay. थोड़ा सा late हो गया. I'm really sorry. Guys, if you can hear me, if you can see me, just write yo in the chat box. You know the drill. Namaste, namaste everyone. Namaste. Yes, I can see people remember the way we greet now. Awesome, awesome guys, awesome. Welcome everyone. Welcome back. Welcome to Vedantu's JEE channel. I hope all of you are doing fine. So guys, whenever I'm looking in this direction, you know that that's the direction of camera, and my cell phone is kept here where I'm reading your chats. Okay, I'm good, guys. I'm good. I'm good. I'm doing good. Awesome. Hello everyone. Hello. So we have RP Pandey. We have some creative names: Sai, Sarvani, Narsimha, Atharva, RTN, and then we have Jayant, Nomula, Dean Ambrose, Dilip, May, Ritik, Shrisha, RP Pandey, Sarthak Purohit, Atharva, Lakshya. Everybody is here. Well, it's very well, guys. Priyanka Gupta is here. Rishi, and the creative channel. Hi guys, hello everyone, namaste, 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 and welcome back. Well, guys, this is me back again with another doubt destroying session. Today's session is on one of the most fundamental topics of your JEE preparation, that's called as laws of motion. Okay, I hope I'm visible properly. I think the direction in which angle is placed for the camera is not right. Now I think it is. Okay, so for people who are here for the first time on the channel, guys, this is me, your Suri Sir, also known as Mogambo. And yes, I'm called Mogambo because when you will crack the examination of JEE, Mogambo khush hoga. Yes, guys. So there are a lot of informations to share as always. First thing first, if you are a student who's preparing for JEE 2020, I know JEE 2020 बहुत डिले होता जा रहा है, बट डिले होने पर भी हमारे पास टाइम है, बहुत सारा टाइम अवेलेबल है. तो अभी भी अगर वीक टॉपिक्स को स्ट्रेंथन करना चाहते हो तो क्रैश कोर्स इज गोइंग ऑन वेदांतु, एंड दिस बैच इज स्टार्टिंग ऑन 26th 27th of April. Okay, so I guess 23rd it is today, and 27th the batch is starting. You can take the advantage. How can you join? Guys, this is the link which is available in the description of the video के नीचे एक description link होता है, वहाँ पे you will find this link along with all the important links. So when you go there, don't forget to use the coupon code SMCC, because the crash course, which is actually worth rupees 30,000, will be yours for just under rupees 6,000. Okay guys, so steps बहुत सिंपल से हैं. यहाँ पे क्लिक करना है, एनरोल नाउ पे जाके क्लिक करना है. डोंट फॉरगेट टू यूज द कूपन कोड. व्हाट इज द कूपन कोड? SMCC. ओके, अपार्ट फ्रॉम दैट, अगर चैनल पे फर्स्ट टाइम आए हो, इफ यू गाइस आर हियर ऑन द channel for the first time or have been earlier here but haven't subscribed, then do subscribe to the channel. Press that bell icon so that you are notified every time when I'm coming live, when other teachers are coming live. Okay, cool. So chalo, let's start. आज का सेशन स्टार्ट करते हैं. बहुत सारे इंपॉर्टेंट क्वेश्चंस आज मिले हैं, स्टूडेंट्स के डाउट्स हैं, और ऑब्वियसली बहुत फंडामेंटल चैप्टर है, सो देयर आर मेनी डाउट्स which are there. So the very first question is being asked by Shakti, and she wants to know that, sir, can you tell us the angle of repose and its explanation? So first of all, what is angle of repose? If I say that there is an object and that object is placed on a horizontal surface. Okay, so if you have an object which is placed on a horizontal surface, say like this, if you will start increasing the angle of inclination, the tendency of this object to slide down will keep on increasing. So there comes an angle where the object will be just about to start to slip. So the angle of inclination where the object is just about to start to slip, or it just starts to slip, is basically you call as the angle of repose. So this is the case when the friction force which is acting on the body is basically maximum. Okay, so if you see at the diagram here, if I say that this angle is the maximum angle which can keep the body stationary, then what is happening here? There are three forces acting: N, friction force, and mg, but I have resolved mg as mg sine theta and mg cos theta. So if I try to balance out the forces, This is body which is just about to start to move, so it is still not moving. Okay, so we say that normal force is being balanced by mg cos theta, and the limiting friction is the maximum value of static friction force, which is equal to mu times of n, is being balanced by mg sin theta. Okay guys, yeah, so I'll put the value of n here, so that is mu mg cos theta, which is equal to mg sin theta, which means mg and mg get cancelled. I have mu equal to tan theta, and you can say theta, the angle of repose, is going to be tan inverse of mu. So this is called as the angle of repose at which the body on an inclined plane is experiencing the limiting friction force. Okay, cool. Next one, guys. On an inclined plane of angle 60 degree, a block of 6 kg is pulled upward by a force F. What is given to us is the coefficient of friction, that is zero point 0.6, and coefficient of kinetic friction is 0.4. So this is mu S and this is mu K. So question asks us to find out the value of the force that you are trying to apply on this body horizontally, rather not horizontally, parallel to the inclined plane. So this force value is to be found for different cases. First case is when the block is stationary, second one when the block is moving with a constant velocity, and the third one is when the block is moving upward with acceleration of 4 meter per second square. So right now what is happening? The block is experiencing a downward force, that is mg sin theta. So this is 6g, theta is 60 degree. So 6g sin 60 degree. This angle, or rather this component, is going to be 6g cos 60 degree. Also, because the block is being pulled upward by this force F, so the friction will have a tendency to oppose the motion. So this is the direction of friction force, and I'm considering it to be limiting in the first case. Okay, so Yash, in the first part, when the block is stationary, there are multiple possibilities for the block to remain stationary. So what I'm trying to calculate in the first case is the maximum value of the force which can keep the block, or rather when it is applicable on the block is still stationary. That means what? The friction force is limiting right now. So that's what I'm solving, because any other value is possible less than that for the capital F. Okay, and this force is normal. So for the first part, I will say that your capital F is basically balanced by 6g sine 60 degree plus limiting friction, and limiting friction is mu n, and normal is 6g sine 60. Okay, so let's call it F1. So this is 6g sine 60 degree plus friction is mu s 6g cos 60 degree. So let's put the value here, 6 into 10. Okay, sine 60 is root 3 by 2 plus mu s का value हमें दिया है 6 by 10. This is 6 into 10, and cos 60 का value होता है half. So we have put that value here. So 10 is cancelled by 10. This 6 is cancelled by 2 3 times. So I have 30 root 3 plus, what do I have? This 2 is cancelling this 6 3 times, so this is 18. So F1 ka value comes out to be, rather this is the maximum force which is applied on the block and the block is still stationary. That value comes out to be 30 root 3 plus 18. Okay, hope it is understood. Remember मैंने यहाँ पे mu s consider किया है क्योंकि block अभी भी stationary है. Second condition, when the block is going to move with constant velocity. When an object moves with a constant velocity, the net force acting on the body still remains 0. So this time the only difference that you will see is that F1 is going to be 6g sine 60 degree plus kinetic friction. That's the basically biggest difference here. Here it was limiting friction, now it is going to be kinetic friction. So the force is going to be 6g sine 60, and this value is 30 root 3. We have found that. And when you are calculating this kinetic friction, instead of putting mu s, you will put as mu k. That means here it will become 4 by 10. That value is mu k into the remaining part is 3. So all in all that you are going to get is, rather let's put that So 6 into g into sine, sorry, cos 60, that is 2. So this is what I have written here, guys. 30 root 3 is your mg sine theta, and fk is basically mu k into n. तो मैंने म्यू के का वैल्यू लिख दिया 4/10 और n का वैल्यू लिख दिया mg cos theta. So this is cancelling for 2 times. So overall the value of, let's call it f2, capital F2 comes out to be 30 root 3 plus, from here 10 gets cancelled with 10 and this comes out to be 12. So F2 का value आता है 30 root 3 plus 12, and for the third part where the body has to move with a acceleration of 4 meter per second square, let me get some space here. Okay, so rubbing off this part now. Okay, Yash, I hope you have understood this much. Now coming to the third part. So for that, I'll have to redraw things again. So this is the force that you are applying on the body. 6g sine theta is acting. Now the kinetic friction is acting and the body is accelerating with an acceleration a. So in the third case, you will say that your force minus 6g sine theta minus friction kinetic, this should be equal to mass into acceleration, and the value of acceleration is given as 4 meter per second square. So this F3 is to be found, that comes out to be ma plus 6g sine 60 plus kinetic friction, which is mu k into n. Okay, so mass of the body is 6 kg, acceleration is 4 given to us. 6g sine theta comes out to be 30 root 3, we found it previously, and mu k n comes out to be 12. So 24 plus 12 is 36 plus 30 root 3. That's basically the answer to your third part. Okay, important part to notice is the value of kinetic friction changing, or other friction ka value changing in the three cases. Here I have considered it as limiting friction, here I have considered it as kinetic friction, here I have considered it as kinetic friction, but in the third case the body is accelerating. Okay, awesome. Next one, a small marble is projected with a velocity of 10 meter per second in a direction 45 degree from the horizontal direction on a smooth inclined plane. Calculate the magnitude of v of its velocity after 2 seconds. This is Ragashri from Kadapa. So Rajshri, first question is very simple. When you are throwing something upward up the inclined plane, the body is going to go up. This is the direction of velocity, but the body is going to experience mg sine theta downward. That means it is going to retard. So if I write v equal to u minus at, why am I writing minus? Because it is retarding. So after 2 seconds, we want to find out the velocity. The value of retardation is going to become g sine theta, and that is 45 degree. Okay. So the initial velocity of the body is given as 10. G is 10, sine 45 is 1 by root 2, and you're talking about after 2 seconds. So this is 10 minus 10 root 2. So when you simplify, this is 10 minus 14.1. So minus 4.1 meter per second is going to be the velocity of the body, which simply means what? You initially projected the body, say, along the direction of the plane, but finally this was the direction of you. The body will start coming down the plane. This is the direction of velocity, which is negative direction. So if this direction was positive, this direction is negative. That's why the answer is negative. Okay, next one, a particle of mass 2 kg move with the initial velocity of 4 I cap plus 4 j cap. A constant force 20 j cap is applied on the particle. Initially the particle was at 0 comma 0, the x coordinate of the particle, when its coordinate, which coordinate, rather I should say its x coordinate, again becomes 0 when the x coordinate of the body becomes, sorry, when the y coordinate of the body becomes 0. Okay, you forgot to mention that. Ragushri, but the coordinate which will become 0 is y. So basically the question number 2 is from projectile motion. We have projected a body like this and it is moving and coming down here. The only difference is this time the velocity is given as I cap and j cap both. So uy, if you will see here, is basically 4 meters per second, which is u sine theta. Okay. Also, if you talk about acceleration, which is ay, is going to be force upon mass. So force of the body is 20 and mass is 2. So you can see that the acceleration is 10 meter per second square. So what you have to find out is when the y coordinate changes from 0 to 0, right? So the y coordinate changes from 0 to 0. That means you are talking about nothing but time of flight. So you will find out 2u sine theta by ay. So 2u sine theta is basically 4 and ay is 10. You simplify this, it comes out to be 0.8 second. That's your answer. Okay. Okay, guys. Utsav, you can watch the replay of the video. You'll be able to understand the previous question. Okay. There are a lot of questions today. Next question. Sir, please tell force due to spring mass system before and after the spring is cut. This is Sarthak from Indore. Similar question is asked by Devina from Kolkata. I have problem regarding questions of spring mass system. If you can quickly revise the concept, it would be helpful. Thank you, sir. So I would rather try to explain it with the help of an example, Devina. So let's have a look at this example here. Two blocks of masses m1 and m2 are being present in the system and they are in equilibrium. The block m2 hangs from a fixed smooth pulley. This is the fixed smooth pulley and inextensible string. So eventually question is saying that you are going to cut this string, and when you are just cutting the string, so just after cutting the string, what is going to be the acceleration of the two blocks? Okay, guys, so let's try to solve this question. So what you see here, people, so if I cut this string, at that point of time, the spring, or rather, let's speak about the situation just before the spring was cut. Okay. So if you have your system with spring still intact, this is where you can say that the spring is being pulling a block, or other spring is being elongated. Say the force which is acting in the spring is spring force, and that is the force which is balancing m2 also. So ये है m2 का weight m2g, और इस ब्लॉक पे राइट डायरेक्शन में स्प्रिंग फोर्स लग रहा है और लेफ्ट डायरेक्शन में टेंशन का फोर्स लग रहा है. Okay, so if I draw the free body diagrams here, m1 has spring force on the right hand side, which is also the tension in the string, and left hand side is some tension t dash, let's call it t dash. And for this block m2, upward force is spring force and downward force is m2g. So when you cut this string, when you cut string S, then what happens? T dash becomes 0. So if T dash becomes 0, Fs at that T equal to 0 remains unchanged. Let's read the question once again. We are talking about finding the acceleration of the bodies just after the string S is cut. So when you are just talking about the time after string is being cut, at that point of time, you are considering that the spring is still elongated. So from here, this force becomes 0. So we can say that now for m1, the only force which is acting on m1 is Fs, which is equal to m1 into A. Okay. Also from this free body diagram, if you will see, for block m2, Fs is being still balanced by m2g. So basically this block will start accelerating in this direction, and this block will say have an acceleration a2, but as you can see, spring force is unchanged, m2g is unchanged, so they are basically just balanced. So what I'm doing now, spring force को मैं यहाँ पे put करता हूँ. I have m1a equal to m2g, so let's call it a1. A1 comes out to be m2 upon m1 into g, which is basically the acceleration of block m1. This is for m1, and for m2, acceleration will be 0 because the net force acting on it is still 0. So point to be understood here is that whenever you are solving questions which are related to spring and string situation, if you cut the string, string tension becomes zero at the very instant, but the spring force does not become zero at that instant. So you have to use the spring force as it is. Okay. Now next one. So what we should do to solve constraint pulley sums? This is Snehit from Vizag. Sir, please explain the concept of constraint pulley, more than 5 to 8, 9 pulleys, and take a few questions on it. This is Tanishq from Baroda. How to solve multiple pulley problems, Atharva from Pune. And next is Akhil. He says, hello sir, please help me solving the problem related to multiple pulleys. And Noel from Pondicherry also asks similar question, or rather his question is different, but it is actually affected by the same thing. Okay. So he says that, sir, in doing string questions, why we take velocity and acceleration along the string to be they are equal. So Noel, I will answer your question first. Whenever you are considering a pulley which has, say, two masses which are connected like this, okay, and say this block is moving and this block is moving in the opposite direction, say this acceleration is a1 and this acceleration is a2, then a1 is equal to a2, because we consider that the string is inextensible. So जितना राइट हैंड साइड वाली ब्लॉक को नीचे आना है, और उनको नाम दे देता हूँ, एक काम करता हूँ, लेट्स कॉल इट ए, लेट्स कॉल इट बी. जितना ब्लॉक बी नीचे आएगा उतना ब्लॉक ए को ऊपर भी जाना पड़ेगा. So that is only possible when both of them are moving with the same speed and same acceleration. But only and only this case, when you have a single string connecting the two blocks passing over a single pulley, then only your V1 equal to V2 happens and A1 equal to A2 happens. For the other situations which are now presenting, the accelerations will not be same. Noel, I hope you are listening. So now in these cases, the accelerations and velocities of block A and B are not going to be same. So guys, for everybody to understand what we do, hi Sarthak, I hope you are understanding what I'm saying. So now I'm considering questions where we have multiple pulleys and multiple, strings connected. The only thing that we will use here is the formula, or rather understanding that the net work which is done by the tension force, T dot S बोल सकते हो, T dot A भी बोल सकते हो, A is acceleration, this should be equal to 0. You know that in the case of pulley and string situation, the internal force of the system is tension, the external force is the gravitational force, because earth is applying the force on block A and B, which is not a part of the given system, while the string and the force applied by the string are basically the internal forces. So the work done by internal forces is always 0. That's basically the trick that we will use here. Okay, let's see how we apply that. So what I'm going to do now, I'm going to consider that you can see that from here, if I start moving up, this is the same string which is passing like this. Okay, that means if for this string the tension is T, for every massless string, remember this part guys, for every massless string, tension is same throughout. Throughout the string, the tension will remain the same for a single string. That means if tension is T here, on passing it here, the tension will remain the same T. On passing it here also, the tension remains T only. Okay, so this string which is being started from here, follow me along with this direction. What you see that the same string is connecting B. So the tension has been drawn same across this all the points of that string. But if I speak about the string which is connecting block A, this pulley is ideal. Ideal means it has no mass. So the total upward force and the total downward force has to be same. So here the tension force will become double the tension which is upward. How it is happening? For this pulley, you can see that this is tension, this is tension. So downward force should also be same. So that is also 2T. I hope it is understandable to everyone. Okay. If you are not getting this part, then actually you need to start from the basics of this constrained motion understanding. Okay. If you are not able to take the directions right. Okay. So now guys, what I'm going to assume, as you can see that in the diagram you need to visualize a bit. If block A starts to come down with an acceleration AA, then block B has to go up with a direction upward and acceleration AB. So guys, now I will write down the net T dot A to be equal to 0. So for block A, the direction of tension is upward, but the acceleration is downward. That means the angle is 180 degree. So it will be 2t into A into cos of 180. That's why minus cos 180 is minus 1. And for B, the tension is T. This was acceleration AA, and this is acceleration AB equal to 0. What I have written? What I have written here? The tension 2t is acting upward, acceleration is downward, so the angle is 180 degree. So dot product is A into B into cos of theta. So this is the first vector, this is the second vector, cos 180 is minus 1. On the other case, if I speak about block B, tension and acceleration have same direction, so that's why T into AB equal to 0. Okay, so guys, now what? You can see that tension will become 0 throughout. So I have minus 2AAA plus AB equal to 0, which gives me acceleration of B to be double the acceleration of A. Okay, guys? Yeah. So you can see, Noel, I hope you understand that acceleration does not come out to be same here. Okay. And now coming to another example here also. So guys, again for B, the tension, let's say, is T, say its acceleration is AB, same string is passing here, so this tension becomes T, this tension is also T, and this tension is also T, because from this point, if you will follow the path that I am following here, the tension remains same because it is the same string. But this particular string that I'm talking about from this pulley has tension 2T. So overall flow for block A, you can see 2T and T are the tensions, and acceleration of A is, say, AA. So overall the net force acting on block A is 3T, that is upward, and on B it is T, that is upward. So now I will write that sigma T dot A equal to 0. So guys, for A, the tension is 3T, acceleration is AA, direction is opposite, that's why minus, plus for B it is T into AB equal to 0. Okay. So tension becomes 0, and from here minus 3AA plus AB is equal to 0. So the acceleration of B comes out to be 3 times of AA. This time acceleration of B is 3 times the acceleration of A. Okay. Okay, guys. Manak Mandal, I'm not looking at any book. I'm just shifting my cell phone from one point to another so that I can see the screen. Okay, guys. Next question. Again, अगर मान लेते हैं कि यहाँ पे tension T है, same string is passing over all these strings that are passing over different pulleys. So you can see that ये सब पुलिस से कनेक्ट होने वाली सेम स्ट्रिंग है. सो ऑल ऑफ दीज आर टेंशन टी. या ओके गाइस, सो दिस टेंशन becomes 2t, this tension becomes 2t, this tension becomes 2t, and this tension becomes 2t. So overall on block A, the net tension acting upward is 6t. This is block A. And for block B, the tension is 2t. Okay, so assuming block B is going to go up with an acceleration AB, and then the block A will have to come down with an acceleration AA, again doing the same thing, 6t into acceleration of A with a minus sign because their directions are just opposite. Yeah, so opposite direction vector will always have dot product negative, plus 2t into acceleration of B should be equal to 0. Okay, so now T again becomes 0, I can say 2 times of acceleration of B is 6 times acceleration of A. So acceleration of B is 3 times the acceleration of A again. Okay, very nice everyone. Okay, yes, Atharva, my Tripali, everybody got it right. Very good, guys, very good. Yes, Tripali, perfect. Now, guys, next one. This question is being asked by Ritesh and Mahir. Ritesh का question है, sir, please explain with example when does the friction oppose the motion of a body and when does friction support the motion of a body. ये बहुत ही अच्छा question है और इसका आंसर सुन के तुम्हें बहुत ही सरप्राइजिंग भी लगेगा. Okay, Ritesh, that friction can actually support the motion of a body as well. Next one, how to solve 2 or 3 block system problem placed over one another. तो यही एग्जांपल में लेने वाला हूँ रितेश, जो माहिर का डाउट है, और सिद्धार्थ ने एक्चुअली ऐसा क्वेश्चन पूछा भी है, सिद्धार्थ फ्रॉम चंडीगढ़, तो उसी को सॉल्व करेंगे. क्वेश्चन पूछा है सिद्धार्थ ने, अ ब्लॉक ऑफ मास 4 kg is placed over block of mass 5 kg and a force of 12 newton is applied on 4 kg block. Okay, only the friction is present between A and B. इन दोनों के बीच में ही फ्रिक्शन प्रेजेंट है. Okay, और वो वैल्यू भी नहीं दी हुई है, म्यू वैल्यू इज नॉट नोन टू अस. So the maximum force that you can apply on A so that block A and B move together. When they are moving together, their acceleration is say A1. The maximum force that you can apply on block A is 12 Newton. ठीक है, आई होप क्वेश्चन इज क्लियर. ए के बी के ऊपर ब्लॉक ए रखा हुआ है, ए को तुम पुल कर रहे हो, उसकी वजह से दोनों ब्लॉक मूव तो कर रहे हैं साथ में, बट द मैक्सिमम फोर्स विद विच यू कैन डू दैट इज 12 न्यूटन. इससे ज्यादा फोर्स लगाओगे तो ए और बी के बीच में स्लिपिंग होना स्टार्ट हो जाएगी. ठीक है, सो क्वेश्चन वांट्स अस टू फाइंड आउट कि अगर अब हम फोर्स ब्लॉक बी पे, नीचे वाले ब्लॉक पे फोर्स लगाना चाहते हैं, if you want to do this, then what is the maximum value that you can consider for force F dash so that the two blocks still move together. ठीक है, सो फर्स्ट ऑफ ऑल रितेश, तुम्हारे क्वेश्चन का आंसर, और भी किसी ने आगे ये डाउट पूछा है कि सर हाउ डू आई टेक द डायरेक्शन ऑफ एक्सेलरेशन, डायरेक्शन ऑफ फोर्स ऑफ फ्रिक्शन. सो प्लीज यू आल्सो लिसन केयरफुली. सो इफ दिस इज ब्लॉक ए एंड दिस ब्लॉक इज बी, मैं दोनों के फ्री बॉडी डायग्राम्स को ड्रॉ कर रहा हूँ. सो गाइज, विच एवर ब्लॉक यू आर अप्लाइंग द फोर्स ऑन, सबसे पहले उसी का फ्री बॉडी डायग्राम बनाना होता है. तो ब्लॉक ए की टेंडेंसी है राइट साइड मूव करने की, तो फ्रिक्शन फोर्स विल ट्राई टू स्टॉप इट, एंड इस केस में द फ्रिक्शन इज लिमिटिंग बिकॉज दिस इज द मैक्सिमम फोर्स. द डायरेक्शन ऑफ फ्रिक्शन विल रिमेन दिस, बैकवर्ड ओनली, चाहे वो स्टैटिक हो, लिमिटिंग हो या काइनेटिक हो. ओके, एंड if this is the action force, the reaction force is going to act on block B. Okay, this is FL. कहने का मतलब ऐसा, block A is trying to move over the surface of block B. So block B की responsibility है block A को slide नहीं करने देने का. A और B के बीच में relative motion ना होने देना is the job of force of friction. So that's why when block A is trying to go towards right, it is experiencing a force of friction towards left that is being applied by the lower surface. And in this process, block A is trying to take block B along with it, and that is why block B is going to experience a friction force towards the right. So Ritesh, you can see that your doubt is when the friction is going to try to hinder the motion and try to make a body move. तो यहाँ पे friction force is trying to hinder the motion of block A and it is trying to make the body block B move together. So block A के लिए it is trying to behave like a retarding force, block B के लिए it is trying to behave like an accelerating force. Okay, now because both of them are moving together, guys, so I can say that the net force which is acting is equal to mass into acceleration. So that is 4 plus 5 into acceleration, that is A1. So A1 का value comes out to be 12 by 9, or you can say it is 4 by 3 meter per second square. Okay, okay, just a minute, guys. So that's the force which is making the acceleration as 4 by 3 meter per second square. तो अगर अब मैं म्यू या लिमिटिंग फ्रिक्शन कैलकुलेट करूं, तो ब्लॉक बी को इस एक्सेलरेशन से मूव करवाने वाला फोर्स है एफ एल, बिकॉज दैट्स द ओनली हॉरिजॉन्टल फोर्स एक्टिंग ऑन बी. सो फॉर बी, एफ एल is equal to mb into a1, and that is basically mass of block B is 5 acceleration is 4 by 3. So limiting friction ka value is 20 by 3 Newton. Okay? Now this value cannot change. Now when you will try to make both of them move by applying a force on block B, what will happen? अब block B क्योंकि वो block पे external force लगा है, now you will consider the free body diagram of block B first. This is the very first and thumb rule. The external force on whichever body it is acting, you first draw the free body diagram of that body. Okay, so block B wants to go forward now and block A will try to hinder its motion. So now the limiting friction is going to try to resist the motion of block B, and the reaction force of this limiting friction will try to take block A in the right hand direction. So this for A, FL should be equal to MA into the new acceleration of both the blocks. So FL ka value is 20 by 3, mass of A is 4. So A2 ka value when you will find out will come out to be 5 by 3 meter per second square. And because both of them are moving together, so F dash max should be equal to 4 plus 5, that is the mass of both A and B, into acceleration A2, that is basically 9 into 5 by 3, that when you simplify comes out to be 15 Newton. Okay, very good question actually. सिद्धार्थ बहुत अच्छा क्वेश्चन था ये. चलो गाइस थोड़ा स्पीड अप करते हैं. Next question is, a heavy uniform chain lies on a horizontal tabletop. If the coefficient of friction between the chain and the table is 0.25, then the maximum fraction of the length of the chain that can hang over the edge of the table is how much? तो मान लो ये वो टेबल है जिसके ऊपर you have this chain which is hanging, and say its m by n portion is hanging, so m minus m by n is on the table. हमें पता लगाना है कि कितना मैक्सिमम फ्रैक्शन हम हैंग करवा सकते हैं. तो अगर मान लो the fraction that is hanging is small m, okay, and the fraction which is on the table is m minus m. हमें पता लगाना है कि कैपिटल स्मॉल m by capital M into 100 कितना होगा, वो परसेंटेज हमें पता लगानी है. Hema Bindu is asking this question from AP. Hema, I hope that you are watching this session. So always and always, whenever you are dealing such question, you can convert this question in the form of a two block system on a table. Okay, like this. You can convert it in this form. So consider that this mass is m minus m and this mass is m. So in this case, what is happening now? I'm interested in finding this ratio of m by m. So what is going to happen here? If I speak about the force, here tension force is acting, here mg force is acting, here tension is acting, and here it is the force of friction which is trying to stop it. So maximum friction की बात हो रही है, that's why it is FL. Okay. So if I say that mg is being balanced by tension for this block, and this tension is basically equal to limiting friction. So mg is basically mu times of m minus m into g, because this is equal to mu n. Okay. So now what? If I cancel g value from here, I have m equal to mu, that is given to us as 1 by 4 m minus m. So m equal to m by 4 minus m by 4, this comes here. So I have 5 m by 4 equal to m by 4. 4 cancel. Small m by capital M is 1 by 5. And if you multiply it by 100, you can see that this is 20% fraction. So the answer is option A. It's 20%. Yes, gravity. Very nice. Gravity giving. Next question is being asked by Vasu Khanna from Najibabad, UP. Vasu says that a heavy box is to be dragged along a horizontal floor. To do so, a person pushes it at an angle of 30 degrees from the horizontal and requires a minimum force Fa. When another person is trying to apply a pulling force at an angle of 60 degrees from the horizontal, he will require a force of Fb. So if the coefficient of friction is 3 by 5, we have to find out the ratio of Fa to Fb. तो डायग्राम में समझा देता हूँ कि एग्जैक्टली हो क्या रहा है. सो दिस पर्सन इज अप्लाइंग अ फोर्स लाइक दिस, दैट इज Fa at an angle of 30 degree. So this is basically Fa cos 30 degree. This one is FA sine 30 degree, and downward is mg also. This is normal force Na, and this is the friction force. Say that friction force is F. Okay, so if you look at this, you can see that FA cos 60 degree, sorry, FA cos 30 degree should be balanced by your it requires a minimum force, so that's why this is limiting friction only. So this is going to be FL, which is equal to mu Na, and you can see that Na is basically mg plus Fa sine 30 degree. This is along the y direction. So Na यहाँ पे पुट करते हैं. I have Fa sine 30 degree equal to mu times mg plus FA sin 30 डिग्री. ओके, सो अब मैं क्या करता हूँ, यहाँ पे FA को इस साइड लेके आता हूँ. आई एम ट्राइंग टू सेपरेट आउट FA. सो FA sin 30 यहाँ इधर आएगा, तो म्यू FA sin 30 डिग्री is going to be mu mg. Okay guys, so from here if I take FA out, I missed out something. Yep, this was supposed to be cos. Time is actually taking toll here. Okay, so this is cos. My mistake here, guys. So from here, FA, if I take common, in the bracket I will be left with cos 30 minus mu sin 30. So FA का value मुझे मिलता है mu mg divided by cos 30 degree minus mu sin 30 degree. Okay, this is your first part. Okay, now second case में ये बोला है question में कि this time you have a force FB being applied by another person, but this is applied at an angle of 60 degree. So this force becomes FB cos 60 degree, downward is mg, and upward becomes FB sin 60, and a normal force NB and a limiting friction again acting here. So I say that FB cos 60 degree is going to be balanced by limiting friction, which is mu into NB. And from there, if I write, NB is basically mg minus FB sine 60 degree from here. Okay, so FB cos 60 degree plus mu times FB sin 60 degree is equal to mu mg. तो FB का वैल्यू हमें मिल जाता है mu mg divided by cos 60 degree plus mu sin 60 degree. This is your equation number 2. Okay, Vasu, I'm going to just leave the answer in terms of ratio. You can finally do the final calculation. This is going to be cos 30 inverse proportionality, cos 30 minus mu sin 30 divided by cos 60 plus mu sin 60 degree. So you can simplify this, you'll get the answer. You have all the values, mu value is given to you. Okay guys, yep. Now next one guys, in this question we have to, this is Mohit who says, sir, how to solve the question where monkey and pulley is involved and a man and pulley is involved. So in this question we have a person who is in the box. Box का mass हमें दिया है 30 kg और person का mass दिया हुआ है 60 kg, and he is pulling the block. The question is asking what is the weight of the reading of the weighing machine. तो यहाँ पे एक weighing machine रखी हुई है. So if he is applying the force of F or T on the pulley or on the string, then the string is going to pull this person with a force T. So this is the force which is applied upward by the system, by the string on the person and the pulley, sorry, on the person and the block. So if I just try to simplify this, the upward force on the person and the block or the box acting is 2T, and downward is basically 30 plus 60 G. So if I say both are balanced, so this is 2T equal to 90 G and T is basically 45 G. Now if I just draw the free body diagram of the person, he is applying a force upward, rather downward, so he's being pulled by the string by this force. This is directly affecting the person, and the weighing machine is exerting a normal force on it, which is also the reading of the weighing machine, and downward is 60 G. So I say that N plus T is equal to 60 G, and N comes out to be 60 G minus T, which is 60 G minus 45 G. So N comes out to be 15 G, which is equal to mg. So the m dash g. So the reading comes out to be 15 kg. That's your answer. Okay. In this one, when the monkey is trying to go up, he is trying to pull the string down with a force of tension T. So on the monkey, the total forces acting are T and mg, and on the weight which is on the right hand side, which is also of equal mass, tension T is being applied by the string and downward force is mg. So you can see that if the monkey goes up with an acceleration a1 and this block also goes up with an acceleration a2, then both are T minus mg equal to ma1 and T minus mg equal to ma2. So a1 is equal to a2. That's what was supposed to be proved. Okay. Archana, मैं दुखी नहीं हूँ. I'm just in a hurry a bit because I have another class at 4 o'clock. Okay. So we may end up the session after very soon in this one. Okay. So guys, let me pick a question which actually explains a lot of things from here. Okay, so I'm going to solve two more questions, one from Yuva because it has multiple explanations required. So he is asking about Lamy theorem. This is Yuva asking this question from Tamil Nadu. He says, what is Lamy theorem? So Lamy theorem is this, by the way, whenever on a body, if the net forces are acting and balancing it and all the forces are coplanar and they are concurrent as well, that means in the same plane. So F1, F2, F3, if they are A, B and C, then magnitude of A divided by sine of alpha, magnitude of B divided by sine beta and magnitude of C divided by sine of gamma are always equal. This is the ratio in which the forces will keep the body in static equilibrium. That's called Lamy's theorem. Okay. Now next question, he says that why string need to be treated as inextensible, massless and frictionless. So in all the questions in laws of motion, we assume that string is massless, inextensible and frictionless for a very simple reason, Yuva. We don't want, or rather it will become very complicated to solve questions where string is also having some mass. So you will have to find the acceleration. When you're finding the acceleration, you'll have to consider the mass of the string. Okay. And also if it starts elongating, then the force of, just like a spring force, kx type of force has to be also considered here. Frictionless is something which will be studied when you are studying rotation motion. That is where there will be friction also, so don't worry about that part. Okay. He says limiting friction, how it is related to minimum force required to negate the friction and move a body against it. So limiting friction is basically the maximum value of the static friction. Whenever you try to make a body move, you apply a force on it. As you are applying the force on the body, the friction force is also acting and trying to adjust its value. So as you keep on increasing the value of your force, the friction force will also keep on increasing. There will be a maximum value till which the body will resist. After that, the body will not be resisted. Okay. So that maximum value of static friction for which the body can be kept stationary is what you call as limiting friction. Now, next one, he says when two bodies are stacked such that the surface of contact has friction, how do you decide the direction of friction? So, your question is the one that I answered there in the question where we considered two blocks, the direction of friction. You can watch this question again. Okay. Now, another question, type of question that I want to solve. Sorry, Vimal will not be taking your question as of now. Don't worry. The another type of question which is very important to tell is this one. This is being asked by Sanjeev from Odisha. He says that a satellite in a force-free space sweeps stationary interplanetary dust at a rate of dm by dt, that is alpha b. So dm by dt according to him is alpha times v. What is happening? Say you have a rocket, okay, and the rocket is basically trying to eject some gases. So the gases are being ejected at a rate of dm by dt, and the mass of the rocket is say m, and it is moving in the right side direction with an acceleration a. So in this case, what is happening? The force which is applied on this dust particles, say that force is F, which is action force. So same force is being applied by the dust particles on the rocket, and that's how rocket moves in the space by action reaction law. You are basically trying, the rocket is trying to eject the gases by applying force on them, and the ejected gases are applying a force on the rocket in the opposite direction. So we say that the force which is acting is going to be dp by dt. That's the second law of motion, and here p will be written as mv, and I can take v from here outside, and I have dm by dt. This dm by dt is given to us as alpha v, and this force is going to be equal to mass into acceleration. Okay, so I'm putting up dm by dt as alpha into v. This is equal to ma. So from here, acceleration comes out to be alpha v square by m. Okay, this is called variable mass system. Yes, Atharva. Similar question is this from here also. If you want to find out, dm by dt into v is equal to ma. So velocity is given to us. This is Yash asking this question from Ajmer. Velocity is 50. dm by dt given is 0.1. Mass of the rocket is 2 kg. Its acceleration is unknown. So this is 5 equal to 2a. Acceleration comes out to be 2.5 meters per second square. Okay, guys. So if you want to ask the doubts as well, you can come to our Vedantu's Telegram group, guys. And on the Telegram group, we regularly share assignments and solution notes, and daily updates are being given. This link is available in the description of this video, guys. You can see that. Okay. So people, if you enjoyed solving questions with me, do like this video. Tell your friends as well. और अगर अभी तक सब्सक्राइब नहीं किया है दोस्तों, so do subscribe to the channel. Press that bell icon as well. Okay, cool guys. So I'm running short of time today. I'll see you again very soon. Till then, keep studying, keep enjoying physics, keep sending me your doubts, and yes, stay safe at your home. Bye bye. Take care.